More than 60% of the buildings of 2030 are yet to be built. That gives us such a tremendous opportunity, right? What we have done until now, we can learn from, and we can really change the way designs are done in the future. See the amount of buildings, see the number of buildings that are going to come up in the next 10, 15 years. It's humongous. And we have a huge opportunity. Every single industry has a huge opportunity to change the course of this development. Next slide, please. So when we started, so the first step when you look at sustainable development is define clear goals, and these goals have to be unreasonable. You can't take goals like I'll reduce 5%, I'll reduce 2% energy, I'll have 5% from solar. These are not the kind of goals we are looking at. If we don't take unreasonable goals, we cannot achieve something big. We cannot achieve something amazing, right? So we took some very unreasonable goals 10 years ago of reducing our per capita electricity consumption by 50%, to source 100% of our electricity from renewables, and to become carbon neutral. So what we've done is we have worked with experts in the field, both locally and in the global context. We have partnered with universities, we have partnered with researchers across the world, and we have introduced a lot of innovative technologies in India for the first time in our buildings. Our buildings have become live labs for a lot of technologies, and some have worked, some have not worked, but that doesn't stop us from doing more research and trying to achieve better and better efficiencies in each and every building. And the most important thing is data-driven designs. We do not look at designs from a thumb rule or from a estimation perspective. It's all data-driven. We had a large building stock when we started in 2008, and we metered each of our buildings. We got a wealth of data, because of which we were able to drive a lot of initiatives, both for existing buildings, and this also gave us a wealth of data for designing new buildings in the best way possible. Okay, next slide, please. So just to give you a perspective of what is the achievement over the last 10 years, the number of employees in 2008 at Infosys was about 80,000. Today we are at 200,000. Our electricity consumption, our electricity bill in 2008 was 225 million kilowatt hour, and last year, FY18, it was 250 million kilowatt hour. So that's an increase of 11% in electricity bills, but our employees have more than doubled. So we've been able to decouple growth from resource consumption. And this has happened with a two-pronged approach. One is the new infrastructure, new buildings that have been built in a totally different way, in the most efficient way possible, and then retrofit of the existing infrastructure. So look at the savings. The cumulative savings is over 1,000 crores. And do you think we have spent so much to achieve this kind of savings? Not even a fraction. Next slide. So coming to new ultra efficient buildings. Yeah, next slide. Next. Yeah. So I'll just give you a comparison of what was our performance parameters. These are the key parameters that we looked at for a building. We build about 2 million square feet every year, right? So these are the parameters that we had for our buildings in 2008-9. Look at the building energy consumption, look at the air conditioning design, it's 350 square foot per ton. This is, even today, most of the corporates work on this thumb rule. And lighting design of 1.2 watts a square foot, and electrical design of 6.75 watts a square foot. This is actually lower compared to the real estate scenario today. Any developer today builds at about 7 to 10 watts a square foot. So these were the Infosys numbers in 2008-9. So next slide. You'll see the benchmarks that have changed and what we follow now. Every single parameter is 50-60% better. at least 50% better. So our air conditioning design is 750 square foot per ton. A lot of people don't believe this. A lot of air conditioning consultants don't believe this because most of them are paid on how much TR they're able to sell to the client, right? So that's also one of the reasons. And look at the electrical load. We are at 3 to 3.5 watts a square foot. So for a 1 million square feet of space, we require roughly about 3 megawatt of connected load, or the peak demand, 3 megawatt of peak demand. So how we have done this is, the first thing is energy efficiency by design. From the concept design stage, we were able to have a say in the kind of building designs that we had. So orienting the building in the right way, having the right insulation for walls and roof, having the right glass, and so on. Yeah, next slide. You can see some of the pictures, some of the, next slide please. Yeah, the most important thing is efficient designs at lower cost. So whenever you talk about ultra efficient buildings, it always means it's at a premium. But what we have proved time and again for every single building of ours is we have efficient buildings at a lower cost. Our building cost per square foot remains the same except for the inflation cost over the last 10 years, but the efficiency has improved by 60 to 70%. This is one of the most important factors, and why we have achieved this is because we have been smart by design from the concept design stage. It's just about smart thinking, having the right team together and doing the right things from the word go. See the type of buildings we have. We don't have glass buildings anymore. We have learned from our mistakes. We have done glass buildings as well, which do not really stand for a tropical climate like India, and we have changed the design of our buildings completely. So orienting north-south, it's a passive design. Next slide. And this gets in a lot of natural light. We have shades. We are just going back to ancient traditional design of buildings, right? They also look good and they are serving the purpose, and they are very pleasant for the employees. Next slide. This is the kind of buildings you see at Infosys today. We don't provide blinds on any of our windows. We have good natural light for all the office spaces, and people really love sitting in these offices. Okay, and it really improves the experience and comfort level and health of employees. Next slide. Yeah, coming to air conditioning system, this is an area which we have put the maximum effort in the last 10 years. We have introduced a lot of technologies for the first time in India, like radiant cooling. We have chill water at 2 different temperatures for high efficiency of the system. We use magnetic chillers, low velocity flow, I mean big pipes, small pumps, that kind of design. And then we use recycled water for cooling tower makeup and so on. See, look at the chiller plant efficiency. We are at 0.42 kilowatt per ton for a building the building in Bangalore. This is anywhere between 0.7 to 1 kilowatt per ton for any other building. Next slide. Yeah, this is the radiant cooling that I was talking about, which is 30% better than any conventional air conditioning system. We have pioneered, this is the first building in India to have radiant cooling, the most visited building by all the universities. A lot of German universities were involved in testing and auditing this building for different parameters. Next slide. Yeah, this is a system that we have developed in-house as an advanced radiant cooling system. The next slide. These are some of the other learnings from global experts to improve the efficiencies of the systems further. Next slide. These are a bit more technical. Yeah, next slide. Retrofits is for existing buildings. A lot of people might think ultra efficient designs are not possible for existing building stock. We have done a lot of retrofits of lighting, air conditioning, and also facade in many of our buildings, and most of these have had a payback of less than 2 years and huge savings. Believe me, the kind of over designs that you get from the consultants are just incredible, and when you actually audit and do the right kind of designs, you will have a huge saving on your operational cost. Next slide. Yeah, next slide. I'll just skip through these. This is DX to chill water conversion, and we have replaced all electrical coils with heat pumps. Heat pumps are becoming very common these days, right, for heating water rather than the electric coils. So this is the per capita reduction that we have had over the last 10 years. We were at 297 units per person per month in 2008, and today we are at 139. That's a 53%. So this is one of the goals that we have achieved, a 50% reduction in per capita energy consumption. Next slide. Yeah, next slide. So since we are talking about smart cities, the most important thing that we've done in all our buildings is smart management. All our buildings are smart buildings. We have at least 2,000 data points coming up from each building, okay, every 15 minutes, and it's like a living, breathing building. So the building adjusts to the outside temperature, adjusts to the number of occupants inside, adjusts the lighting, adjusts the air conditioning. So everything ramps up and ramps down depending on occupancy, depending on the weather. So it's smart in that way. And also the analytics from all this data that we collect help us predict what is the breakdown that is going to happen in the next 15 days, next 1 month, so that corrective action can be taken. So this is one of the most important aspects. And after building a very efficient building, if you don't monitor the performance, if you don't ensure that the performance is maintained over a longer period of time, there's no point, right? So we want to ensure through this granular level monitoring that the efficiencies are maintained through the life of the systems. This is something on data centers. Next. This is the kind of efficiencies that we're looking at in the data centers, some of the most efficient data centers that you can get with a power utilization effectiveness of 1.12. Next, on renewable energy, today we are about 50% on renewables, both purchased green power and also the on-site that we have within our campuses, about 16 megawatt of on-site that we have. Next, yeah, this is one of the state-of-the-art solar plants that we have in our Hyderabad campus. It's the most visited solar plant and one of the most efficient solar plants globally today, with a very, very high plant load factor, and a 6.6 megawatt installation generating about 12 million units a year. This has been documented by NREL in the report, and the director of NREL was also visiting this plant and was very impressed with the kind of innovation that has gone in, because it has different technologies in a single plant, different technologies and also different tracking mechanisms. Something on water conservation, we are very particular about water conservation. In the last 5 years, we have invested a lot of our time and effort in water conservation, because you know the grave situation with water that we face today. So everything to do with end use conservation. Yeah, I have a few more slides, 2-3 more slides. Yeah, end use efficiency measures like aerators and pressure compensating valves and so on, which have reduced our water consumption to a great extent. Next slide. So look at the per capita water consumption. It has come down 57% in the last 10 years. All our campuses are zero discharge campuses. These are all because of smart designs. Not a single drop of water leaves our campus, not a single drop of sewage leaves our campus. It's treated 100%. 100% of the recycled water is used within the campus, and 100% of the rainwater is collected within our campus and used for drinking purposes as well. Next slide. On waste management, one of the most attractive, most beneficial things that we've done over the last few years is having biogas plants. We have food courts. We have food courts in these campuses. Our campuses are like mini cities, right? We have food courts, large food courts, and there's a lot of food waste that comes up with these food courts. What we do is we take all this food waste and treat it in a biogas plant. We generate biogas, which is used to replace the LPG cylinders used in the food court kitchens. So it's a closed cycle. We have biogas plants in all our campuses today. Next. So the most important thing that I wanted to say is, we have this tremendous opportunity to build our cities in the way we have done our campuses, right? Our campuses are nothing short of cities. We have everything in our campuses to live and stay, live and work, and also recreation. So this being said, data-driven approach, goal-oriented approach is very important, and use of IT for monitoring, use of IT for ensuring proper designs, because there are a lot of software that can optimize designs of buildings before you even build it. So a lot of things are possible, great opportunities. through innovative and collaborative approach, I think we can achieve some great things for our